This is Josh White with JW Math Tutoring. Today's video is going to cover Desmos hacks that you can use on Bluebook practice tests 5 and 6. So let's go ahead and take a look.
Life is a dream that calculus could never predict.
Entirely in Desmos. So all I'm going to do is I'm going to take the graph of this function, highlight some points from it, and then take those points, do a regression in Desmos to get the actual equation of the graph that we're given for f of x, and then just shift f of x up by 5 and see which graph from the answer choices matches my new graph. So it sounds like a lot, but it honestly doesn't end up taking that long. So here's my first point, 1, 9. I'm also going to use this point right here, 3, 3, and then there's another point right here, 9, 1. Okay, so those points are all basically at the intersection of integer values. So just enter those in. All right, now I'll go ahead and do a basic regression for a rational function. So basic form is just going to look like this: some number on the top over an x, and it could and plus or minus a number. So the a and b values are the the two values I'm looking for. So this gives me an a value of 9, so there's a 9 on top, and b is just 0. So this function that's graphed here on the screen is just really 9 over x. All right, so now I'll just go ahead and graph that. But I'm going to define it set it equal to f of x instead of y, and the whole reason is because now I can easily do a translation. So here's the original function. Now the new function, the answer choices are this function just with a plus 5. All right, so I'll turn off the original. Now when I'm looking at just this part on my screen here, which of these answer choices match? Well, obviously not A. A goes way down here to -4, okay? That's wrong. Looking at B, this goes down and gets real flat close to 0 in terms of its y value. That's wrong. C, this goes down and gets real flat close to 1. Okay, that's obviously wrong. By process of elimination, it's going to be D. And you can also see this one goes down and gets real flat close to 6, although technically it does actually approach 5, if you go out far enough. But D is going to be the correct answer. And again, that's how we can do this entire problem in Desmos, just by doing a rational function regression. Now, here's an alternate method you could use to solve this problem. It's basically the technique of picking numbers, and I'm going to use Desmos to help expedite the process and do it in basically a much quicker and more efficient manner. So what I'm going to do is first type in the original formula. And I'm going to define some values for n and c. So let's say n is equal to 3, and we said c equal to 2. All right, and now that gives us p equals 51. All right, so those are basically the numbers I picked. P is 51, n is 3, c is equal to 2. All right, now what I'm going to do is go through the answer choices, plugging in p and n, and seeing which of those values gives me c value equal to 2. So first, let me just clear this off. First answer choice. Now, t I already said was 51. You just jot that down. N I already said was 3. Okay, is c equal to 2 here? No, it is not. So now let's try answer choice B. Change that to a minus. Does c equal 2? Nope, that's wrong. Okay, let's now try answer choice C. Does c equal 2? No, it is wrong. So by process of elimination, it's going to be D, but we can also just confirm that when we type in the formula for D, we get c equal to 2. That is the correct answer. So Again, the strategy used here, the overall process was picking numbers, except I used the Desmos calculator to evaluate the formulas, basically doing it in a much quicker manner than it would be plugging into a handheld calculator. So if we go into Desmos, first of all, you could do picking. One way to do it is picking numbers, but um, we go into Desmos, and I'm going to graph. Let's see here. The first thing, actually, I'm not going to graph it. I'm going to do an expression. I'm going to add some sliders. I'll just move them to whatever, whatever random value here. Okay. Now I'm going to do the same thing with the answer choices. And I'm going to see which answer choice has the same value as this top one. So that one is obviously not correct. Checking answer choice B, 84 AK squared over K. Okay, that doesn't match. Not correct. 42A times K plus. Checking answer choice C. That is not correct. So, okay, process of elimination, it has to be D, but just to confirm, notice we have the same exact value. And like as you move this, they will remain the same, regardless of what numbers. I mean, obviously K has to be greater than 0, but, again, these numbers will be identical. Therefore, correct answer is letter D. Here's how you could do this in Desmos, though, just to confirm it. Okay, so we have you put in a table here. I'm going to put in the negative 24, 0, and I'm going to put just a negative, just a random value here with the point, the f of 24 point. And then I'm going to do a regression. Okay, so what I did is I did a table with 2 points. The first point is the negative 24, 0 point. The second point is the f of 24 less than 0. So I just picked some random negative number here. And now notice it gives us values for A and B. And so now you could just go through all the answer choices and confirm. Is f of 0 24? No. Is f of 0 negative 24? No. It looks like for this one specific example, f of 0 is negative 7.701. So that does not have to be true. And then for now, you can easily look at it. Well, A is less than B. Negative 1.44 is less than 24. So the correct answer is D. And again, you could pick different numbers here. You could make this negative 20. You could make this, negative 2. However it works out, you're going to get that D is the answer that is correct. All right, next up, question number 14. So here we have a question that deals with an exponential function. Okay, there's 2 ways to solve this. It's really kind of like, I guess, yeah, there are 2 ways. Let me put it this way. There are 2 ways to solve this. One way is just straight back solving using Desmos, and I will probably do that way first. And then after that, I'll show you how you could technically also use picking numbers. So you're given this general function. So let's go to Desmos. Okay, so here's the original function. And they say it can be rewritten as 1 plus p. Now my p these are my answer choices I'm plugging in. Okay, so which of the following is closest to the value of p that if you plugged it into this other form of the function down here, it would be equivalent? So notice this first one is very, very, very close. It's not quite identical. I mean, it's pretty close over here on the left, but once you get past like about 15 or so, they start to separate a little bit. But it is still pretty, but it also says closest, so it might not be exact. So let's check the other answers and see, do they get any closer? So if I change this to 21, notice it gets further away. What about 46? Nope, even further away. Again, we're looking at the blue. The blue is the one that's changing, and now 96, no, even further away. So 16 is clearly the one that is closest to the original. So correct answer is going to be answer choice A. Here's an alternate way you could do this in Desmos, which will be much, much easier. So just going to do a quadratic regression. I'm going to enter in the 3 points that were given here on the graph. So we've got -2, -6. We already saw -1, -8. And we've also got 0, -6. Now, quadratic regression, and I'm going to do it in standard form. Now, you can either just look at B and C right there, or you can just multiply them in the next line and see that it gives you -24. So honestly, this way is so much quicker, so much easier than doing the math out by hand. But either way, correct answer is -24. An alternate way that you could do this is you could get the actual equation of the line, and I'll just show you quickly, how we can do that. And then it'll be a little easier, like to see that, to see it as well. All right, so if we go to Desmos, okay, so we create a table. Notice we've got a point here, 0, 3 already. That's the y-intercept. And there's also a nice point, it looks like, right here as well, -1, 7. All right, so this is the equation of our given line. So I'm just going to define that as f of x. Okay, get rid of this. So now all I need to do is basically take that and shift it down 19 units. So I'll do a vertical translation down 19 units. So here's my new line. Okay, so first of all, it's obviously going to have the same slope, and we can see here from the graph, so its y-intercept is -16. So the equation of this new line, this basically just determines it. It's, you could say whatever, f of x equals -4x minus 16. Or if you want to switch it, because they have the y-intercept first, -16 minus 4x. So now basically like D is +16, C is +4, and then but they have the minus in front. That's why it has to be letter A. So that's just kind of like an alternate way that you could think about or solve the problem. Or you could also, just to show you, just do it this way. X increased by 400% of X is 60. I just literally took the words and made it into an equation just with the percentage, even in there. And notice it gives me the answer right here of 12. X equals 12, it graphs this vertical line. That's the solution. So this is just a way you can honestly do this question in Desmos in 5 seconds and get the answer. Here's how you could solve this entirely in Desmos. So we bring up the calculator. Okay, so all I'm going to do is use Desmos to find t. And the way I'm going to do that is I'm going to put the point that I have into a table. And then I'm going to do, technically it's a quadratic regression. I'm just going to type exactly what I have here. Oh, it needs to be x1, x1, okay. So this just tells me, spits out to me, okay, t has to be 24. All right. So now you could, you could zoom all the way out and you could see, okay, when x is 0, where's the y-intercept? Well, it's up here at 336. If you don't want to do that, you could just type g of x equals x plus 14, 24 minus x, and then you could do g of 0 down in the next line, 336, and you could just get it that way as well. Okay, so that's how you could do the entire problem. All right, so what I'm going to do is I am going to just graph the function Okay, so here's the function. Now, the problem is the values are not great in the sense that they're decimals. Ideally we would look for like something that's like right on a an exact integer value, but we'll just use the x and y intercepts. That's fine. So what I'm going to do is notice here the first one is 0, 3.33333. So if I type enough things here, yes, this comes up. So technically the first point is just 0, 10 thirds. Okay, so I'll make a note of that. And my x-intercept, let's zoom in here, see if I can get negative 0.2273, negative 0.22727. Let's see, does that give me anything nice? Okay, yes it does. It gives me negative 5/22. So notice all I did is I basically just kept repeating the pattern there. And you can zoom in even further, even more, to just try to get, yeah, 0.22727. Okay. So now I'm going to calculate the slope. So the y-intercept value, so for the top one, I'm going to do the 10 thirds minus, 10 thirds minus the y value for my x-intercept, which is just 0. Now divide that whole thing by the x-coordinate from my y-intercept, which is 0, and then minus the negative 5/22. Okay, so notice here I've got the 14.66666666, okay, 7. So I could enter in 14.66, which we know is correct. I could round it and do 14.67, also correct. Or let's see if it'll give me, yeah, it actually gives me, because I use the correct fractions, 44/3, the equivalent fraction as well. So that's how you could, again, basically, given the equation of a line, that's how we can calculate basically the slope of the line by just grabbing the x-intercept and the y-intercept, essentially manually typing in the slope formula and then getting the value that way. Now, let's say I wanted to do this problem using the strategy of picking numbers. Okay, so I'm going to use Desmos to assist, but basically I'm going to pick numbers for B and C, and then based on that, I'm going to find the value of A, and then based on what I know A is and what I know B is, I will find the percent of B that A is. All right, so let's slide this over. Okay, first I'm going to define a couple things. I'm going to start with C being 100, and then I'm going to define B as 83% of C. Okay, so that just means that B is 83. Next, I know that A is equal to the sum of, 2241% of B plus C. All right, so far what I've determined is if I choose 100 for C, that makes B 83 and that makes A 4101.03. We could just, whatever, probably round it off to 4101. All right, so now what percent of B is A? So you can actually just type, X% of B is A. The problem is, notice these answers are going, gigantic numbers. So what you're going to have to do is basically like scroll way out here and you can see it's 4941. So what percent of B is A? Well, 41%. You could also have done basically like just use X, B equals A. And then notice, let me just zoom back in here and zoom out a little. If you do it this way, it gives you the decimal value, which is 49.41. Then you just have to remember to convert it to a percentage. Multiply by 100, move the decimal over twice, and you get the same answer, 49.41%. So this is how you can do the problem by using picking numbers. And again, you can do the entire thing in Desmos, just going step by step by step. Next up, question number 20. This one, there is actually a very quick and easy way to do entirely in Desmos. I will show you that first because it is so quick and so easy. Then I'll show you how you could actually do it by hand. So what I'm going to do in Desmos is I'm going to put in the 3 points that were given, okay? Enter them into a table. All right, then I'm going to do a regression for this g of x function, okay? And it tells us that f of x is a linear function. So on the top of my, uh, in the numerator, on the top of my overall function here, I'm just going to put mx1 plus b because that's what a linear function looks like. Then on the bottom, of course, we'll put the x plus 3 that we're given. Let me just zoom in here. Okay, here's the graph of it, but we don't care about the graph. All we care about is what is the y-intercept of f of x? And f of x is this part, represented right here. Well, the b value is 36. Correct answer is letter A, 0.36. That's the entire problem, done in, I don't know, was that 20 seconds, 25 seconds maybe? And you can move on to the next question. Now, here's how you could do it in Desmos. So what I'm going to do is I'm going to make a table. I'm going to put my 2 points in, +7 and -3. Okay. I'm also going to just start with a equals 2, and then I'm going to do a quadratic regression. You have to define a, or you have to plug in a number for a in the regression statement either way, because if you only have 2 points, otherwise it's not going to work. It's not going to give you it's not going to work out correctly. So now you could check what's a plus b. Is it negative? It's -6. Okay, that confirms that a is the correct answer. And then if you want to, you could also move it to 3 and see it's -9. Okay, not there. What I mean? Move it to 4. Okay, -12, not there. But this is how you could do it, again, entirely in Desmos.